Alright, 15C, we're going to see how it's the radical in the denominator shows that b is on the outside, but I'm not sure that that's the way it was meant to be. So we'll do both. We'll do one with the b on the outside and then one with the b on the inside of the radical. So first we'll do the one with the b on the outside, just like it looks on the problem. Okay, so I'm going to write it as this. It's going to be, so the first one we're going to try is 1 radical 27 a cubed b squared over 3a to the 6th and times 1 over b, because we're going to treat this b like it's outside. So 27 over 3 is 9, and then a, so that's a 9 right here, and then right here I could reduce the a's, and this is a to the 3rd right there. So I have, and then this b squared comes out, and then the square root of 9 is 3, so this is going to be 3 and then b over the square root of a cubed times b. So this b and this b cancel, so I have 3 over a cubed, like that. Well, I need to multiply top and bottom by a cubed, by square root of a, so that now I have a to the 4th right here. Like this. So that means I have 2 pairs of a's inside the radical, so that means 3 square root of a over a squared. So that would be treating it like the b is outside of the radical in the denominator. Now let's say that it was a typo and they meant for the b to be inside. Okay, so that would be the second one. So that would be this. B inside. So see how it's different from the first one? B inside. So this again is 9, same as before. Right here, this b cancels and then cancels with one of those. And then a to the 3rd cancels, and I would have a 3 down here. So it would be square root of 9 is 3. The b still inside, and then right here I'd have square root of a cubed. So I'm going to multiply by square root of a, and so I would have 3 square root of ab over a squared. So depending on whether this b is inside or outside the radical would depend, that would determine if it's this answer or this answer. Okay, so this is assuming b is on the outside, and this is assuming that b is on the inside of the radical. For letter D, let me just draw a line to separate it because it's kind of messy. We look at the denominator, and we can write it like this. We can say it's m to the 6/3. Well, m to the 6/3 is m squared, right? So this would be m to the 3/4 times n to the 1/2 over m squared. And that's all we would do, because if you try to combine these m's, you would have a radical in the denominator, then you have to simplify it, and then you end up with the same old answer. So this is as much as you can do. Okay. For letter E, move it up a little bit. When it's power to power, you multiply. So negative 2 times 1/2 is negative 1. So this would be x to the negative 1, which is 1 over x. Okay, on letter F, what I did is I broke it down into powers of 3, because 81 is a power of 3 and 243 is a power of 3. So, and so notice how they're all cube roots. So I just wrote 1 cube like that. And then 3, this is 3 to the 4th, that's 81. And then 3 to the 5th, that's 243. So this is 3. You add the powers, so 5 and 4, so that's 3 to the 10th. Okay? And so there are 3 groups of 3, right, inside, because 3 goes into 10 3 times. So that means that I can take out 3 cubed from here, because there's 3 groups of 3s here. And then you have 1 left over. And that's the one that stays inside the radical. So times cube root of 3. And then this one is 27, right? 3 cubed. And that's your answer. Okay? Okay, so 45 is 9 times 5. And 9 is a perfect square. M to the 4th is a perfect square. There are 2 pairs of 2's, right? With 4. So the 9 comes out as a 3 because that's a square root of 9. The m squared comes out. For the n, I've got 3 pairs of n's, right? And 1 left over because I've got 7. So the 3 pairs come out, so n to the 3rd. And inside the radical, I still have the 5 inside and the n inside. And that would be the final answer right here. For h, similar to e, that when it's power to power, you multiply. So the straight out answer would be x to the negative 15 halves. But then we can't leave the exponent negative, so we write it as 1 over x to the 15 halves. You could also write it as 1 over the square root of x to the 15th, because the 1/2 is square root, right? So you don't have to put the little 2 if you don't want to. And then you could also say, okay, we're going to simplify. And this could be written as there are 15 x's inside, so that means that there are 7 pairs, right? So 7 pairs. And so you still have 1 left over, like this. Don't forget the 1 over. That would be another way of writing it. And yet another way of writing it that I didn't have on the answer key is where you take, so here's 1. Here's another one, and there's a 4th way, because you would have to rationalize the denominator. So that would be, we take the 1 over like that, then we multiply it by radical x over radical x. So then that gives you radical x over, this becomes square root of x squared, which is x, and there's already 7, so that would be x to the 8th. So all of those are possible. These are all equal to x to the negative 15. For number 16, they want you to state any excluded values. So basically an excluded value is a value that makes the denominator 0, equal to 0. So for part A, or problem A, the only thing that makes the denominator 0 is if x is 5, because 5 minus 5 is 0. So you would have to say x cannot equal 5. For B, notice there's no x in the denominator. So nothing will make, no value of x will make the denominator 0. So this one you would say none. No excluded values. For C, you would have to factor first to see if it factors. So this is negative 6x squared. And if it doesn't factor, we would have to use quadratic formula. Let's see, negative 6x positive 1. Right? That adds up to negative 5. So I'm going to use a little box. 2x squared minus 6x, x and minus 3. Greatest common factor. And then negative 3 and 1. So the factors in the denominator are 2x plus 1 and x minus 3. So the excluded values, x cannot equal, what makes it 0 is negative 1/2. What makes this one 0 is 3. So these are the excluded values for C. D got moved to the bottom of A here, and so you look at this denominator, and the only thing that makes it 0, so you solve it for 0, subtract 3, divide by 4. So then we say, divide by 4. So we say x cannot be negative 3/4 because that would make the denominator 0. Alright, so for part A, the LCD is the product of x minus 1 and x plus 4. And so I went through and I multiplied the LCD to each term. Okay, and I used the same color so that it's easier to spot. So in the first term, x minus 1 cancels, x plus 4 cancels. In the second term, x plus 4 cancels, and in the third term on the other side of the equal sign, x minus 1 cancels. So what are we left with? From the first term we have x plus 6. From the second term we're going to distribute this here. So that gives me negative 6x plus 6. On the right side, we're going to distribute the 1, so it stays the same. Okay, so I'm going to combine like terms, so I've got negative 5x plus 12 equals x plus 4. I can subtract x, subtract 12. So that gives me negative 6x equals negative 8. Divide by negative 6. So x is 4 over 3. Okay, for number 12, the first thing I did is I factored a negative 1 out of here. And so it looks like this. So then the LCD, excuse me, is, notice how this is the same factor as that one. So the LCD is negative 1 times x minus 5. And so I went ahead and I multiplied that to each term, and now I'm going to cancel any common factors in top and bottom. So here x minus 5, x minus 5, x minus 5, x minus 5, and then minus 1 and minus 1. Okay, so what are we left with? We have on the left side, negative 1 times 2x is negative 2x. On the right, we just have 4x minus 10. So I'm going to subtract 4x. So that's negative 6x is negative 10, so I'm going to divide by negative 6. And so x is positive 5 over 3.